yeah, I'm taking. That's really, I think that's about as much as I can get. Whoa. You've caught me red-handed on the bench, building up our illuminated heater control fascia panel. They're not normally illuminated, they're normally just a piece of aluminium trim with the markings on, screen printed on most likely. On the facelift Cortinas, they decided to illuminate this based on feedback, but on pre-facelift cars, slopey dash, you don't get any lights, so you can't see where your heat controls are in the dark. It is a real pain on Cortinas, hard to do. So, courtesy of my printer friend Mark3 out there in Chorley, hello Mark, he has laser cut me some plastic, and we've made, it's a kind of like 2-layer affair. You've got a piece of plastic at the back there, and then the symbols are cut out, so Mark scanned this into his computer, and then he's got a nice label cutting machine which just cuts this out, and then the holes there, you lay the colour pieces in. So in this case we lay a little red square into the hole so it lands on the perspex. That makes it clear all the way through. Then over to me to drill out in exactly the right places little holes, and then to solder in very minute LEDs. I salvaged them from a car bulb, LED car bulb, but you could get them off the shelf. I just happened to have this in stock, so we desoldered those. Just used my air-powered desoldering, flow soldering station on this. It's just quicker just to pull them off, save damaging them. Then using some very fine copper wire, there it is just in my hand, really fine stuff this. It's insulated, but you scrape off the insulation with a knife, and once you've done that, it exposes the copper, and once you expose the copper you can then build a sort of miniature loom, which is what I've done, really tight. There's not a lot of space and there's not a lot of room for the loom. However, you go along and you micro solder. I use a very fine iron. I'll show you the iron that I was using on this, just coming from the right hand side of the screen. A very fine tip, a 12 watt Antex 12 went in just to do the micro soldering there. It was starting to get just beyond the range of my glasses, so I swapped glasses to some more powerful ones. I needed them to do it. And then I use a 2-part epoxy just in a puddle on the cardboard there. It's a 2-part epoxy quick setting, and we're going to just, once we tested it, so we know that it worked, we're going to create a little flying lead hook up here with a stud pin to hold the wires, because it's very delicate this. I've engraved a channel into the aluminium escutcheon and then laid the cables carefully into the channel, very carefully, just using my little pick here, again coming into the screen. I just laid the little I twisted because you can twist the copper together. You'll never believe where I got the copper from. A scrap Cortina relay. It was a rusted up one, so I just nicked the windings off it so you can see bits of cable hanging out. We repaired one of these, if you recall. So that's where I pinched the copper from, but you can get it on the spool. Didn't happen to have any, so needs must, improvisation and everything. We did that, and then the cables can handle the current. I've doubled up there, and it's daisy chained across, and well, I hope it can handle the current. It certainly hasn't shown any signs of any problems. That cable is very fine, but I'm sure it'll be okay. We're limiting the whole lot through a 100 ohm resistor as well, so I could calculate the current out. I'm not going to, I'm just going to see if it works. We'll leave it on for a couple of days. If it lasts that time, it's going to last. I'd imagine we're going to be okay. We can power up just about power up. I'm looking as I speak to you without breaking continuity. I think we can power up. Yes, we can. I'm just going to grab a cable. Hold on. I'll power up. We're on. You can just see it lit up. I just lost you on screen there, sorry, but I can't show you the flip side yet because we're gluing it at the moment. So I'm going to lay some more 2-part epoxy in, and it's going to creep into those little channels I've cut out and lock all the components down so they're solid. Clearance wise, don't worry, we checked clearance wise, and there's the back of the panel where it comes, and there's plenty of holes, room, and the heater sliders, the actual control rods, don't hit it at all. They just operate here, look, like this. So you're in those grooves, so you don't touch anything. So it should all work. Ruby's got the same, slightly different on Ruby, just different LEDs on Ruby, and cable wires like this, which were a bit more bulky. I've just tried to get it a little bit more streamlined. So it's the only way you can get it. The light will shine through the cutout here, and then you'll get each symbol will illuminate, and then the arrows there, they're in white. You've got a fan symbol which Mark's made, and that just lays into that circle. That's actually beveled out, you know, if you see, because this is laser cut vinyl on top of a piece of clear perspex, not perspex, but sort of flexible clear plastic, which I supplied. Then I just Stanley knifed out. Mark didn't laser cut the plastic. I put it on a cutting board and cut it out. Mark laser cut the labels. So that will give us illuminated panel. I can't bear draw. I mean, Swampy's not got this, and I could do a building 2 really. In fact, I could do a building another one as well for mid green GXL, because it's just one of them things where you, once you've had it, Ruby's got it, you just think, oh no, that just doesn't, the dash just doesn't look, looks like a bulb's out on your dash basically. Just one of them annoying things, which this is the only way. You could get this made in clear perspex. You could use fibre optics perhaps as well. There could be a number of ways. Probably a nice way to do it would be have this in, use total internal reflection, the principle of light bouncing within an object, a material. Typically there's a type of perspex that you can use. It was used on model railways a lot, and the light would refract inside it and illuminate the whole plastic, and you just have to have one bulb then, or maybe one at each end, and it should shine through the symbols. That perhaps would be good. That's another way of doing it. This way we're on, we'll make a neat job. So I'm just going to apply a bit more glue there now, a bit more resin. There it is, that resin, it's good stuff. I'll show you a bottle of the resin in a minute. So that's what we're doing. One of those jobs I just wanted to get out of the way. Quite intricate, quite tricky, quite tough. Okay, join me on the bench then please everybody. 100 ohm resistor just by my little finger just keeps the current down. There's no need to drive these LEDs at full power. They just don't need it. The brightness required is nothing to light up that little Escutcheon panel or that decal panel, whatever you want to call it. So there's the resin, quick setting in about 15 minutes, like a gel type finish, but it's solid, and that's encapsulating. You can just see the minute cable inside there, keeps it so nothing's raised, and they're nicely recessed in. If you caught this, you've got a much better chance that the cable's recessed, so we should be alright with that. Flipping it around, it might be bright on the screen, don't know, for you. There you go. You can hopefully see that lit up, I'm sure you can. So all we're going to do now is diffuse the light a little bit. I've gone off your screen, sorry, let's use the helping hands. We're going to diffuse the light a little bit with some more resin, because these backwards, because these LEDs slightly set back. There's a couple of mil recess in each of those holes that I've milled out or drilled out, and we put a little bit of resin in now, and it just diffuse it a little bit. That one's got some in, you can see. That's what we're looking for. We don't want it too harsh. And then look how this panel goes over. Which way round are we? I'm blinded. There we are. You can see how it's going to start to work. Look how the red straight away comes in very nicely. A little bit of glue just to trim there, you can see, and a little bit of plastic, just scalpel in just to fine tune that little corner. But you can see now we'll apply a decal. Across to the right in my storage drawers, my sheets very kindly supplied, as I said, by Mark III, and there's some colour sheets here. Some triangles is what I'm looking for, the triangles in white, or we could put the the fan decal on, a tiny little minute logo of a fan to copy what we had. They're all wrong colours. Digging into the stores to find the colours that we need. May have to take a commercial break just to find those, but they are around. I'll show you what I mean. Jumping into the screen there, it's all some printouts. We did a bit of trial there. There's some ones in yellow, but they're very good. Just need to get we need blue there, and then the rest are triangles, white, just a plain circle on that one, then the fan on this one here. So that's what we're going to do. It's going to look quite good. It's going to illuminate, and there's no backlighting from it, so it's not going to light up through these slots. Now you could, if you're really smart, put some felt liners behind here so that you can't see in and the felt slides. I might have tried that, and for some reason it didn't work. I'm going to revisit that idea, just so you can't see through. Just neaten it up a bit. Some felt cloth just at the back. And I think, if I remember rightly, I tried that once and it interfered with the controls, but I'm sure it can be done. So that's the principle of operation with this. All we've got to do is take this out. So let's just flip out that. You'll cut to this with the decals all inserted, but that's how we do it. A little blue one there for cold. You'll see what it's supposed to look like by getting an original. And you can see the fan logo there, see? 2 triangles, a circle, a fan, and a blue square for the hot and cold. So it's a great little feature which I like, and I don't think it detracts from the originality of the car, because you wouldn't know that that's, I mean, you can tell it's repro because it hasn't got that satin finish that the aluminium trim's got. It's more gloss. You could put a matte, clear matte over there, film possibly. I'll have to look into that. It's possible to do, but I think it's, you know, it's going to look smart, and unless your side lights are on, you don't know. And then when your side lights are on anyway, it just looks the business because it looks like it should. The colours light up just like that red square is doing there. Red square, let's march across it. Right, I'm going to put some resin into these little recesses and just diffuse the light just a little bit more, and that's ready then. So you're overhead, quick little trip. I didn't show this being assembled. I didn't even know if I was going to make it, to be fair, everybody. I built it as I went along. I thought, what can I do? I mean, I had various LEDs flying around. I'll just show you a few ideas that I had. Tried these, chopped off LEDs, grinding off the heads off the LEDs, too bulky. These slightly large button ones were almost okay. They could have gone in actually, but I didn't have enough in the right colour, white. I had plenty in red and orange and amber. They could have worked, but then I found this bulb. Look at this bulb that I found in stores, and that's got the little LED squares attached in a cluster of 5. So I just desoldered those out, picked them out, and then, as I explained just a second ago, to get the cable, we just dissected this relay here, and that gives you, it's tough stuff. I can pull, and that's not fragile cable, which makes it good for this job. If I, you know, I'm going to hate snapping easy, so it was good for putting in here. I could wrap round and push and tuck down. I didn't make it exactly the right length for some of the runs, so what I did was just double back on itself, and because it's so fine I was able to just bunch it and tuck it in. The only thing that I didn't do is check the current rating through that. What I did do though is feel if the cable was getting warm, and I did try and overload it and short it out as if it blew the cable apart. The transformer was able to melt the cable on a dead short, so it could probably, you know, you're talking milliamps rating through this, and you can calculate the volt drop across these and calculate the forward current and stuff. But if it works and it ain't broke, do you know what I mean? So there you go. And it would be getting hot and stuff. You know, that's cool. No problem with that. As I say, I'm going to leave it on. I'm going to leave it on for a few days. It's going to be on a multi-plug here, so when you're in the car, it fits in this way. These on a Cortina, you always pry them out. I just always use a hook to hook these out. They're just pushed in, they don't have any screws. Look, they're just clipped in there, and they just pop into those kind of like retaining studs. So you'd withdraw that and undo the plug, and that's it. If you wanted, you can put the original one back on, but you're not going to know anyway, so there'll be really no point. But if you needed to service it, if an LED failed, you have to build another one and fit it in on the same plug. Takes about half a day, 5 hours, 4 hours, probably less now. I know how to do it. I reckon I can build one of them in about 3 hours. But it's non-serviceable. If one LED goes, well, you could break into it. I suppose I wouldn't like to start trying to redo that now. To be fair, it's sealed, set and forget. Them LEDs will last the life of the car. Alright, so that's the principle, that's the job. Had to be done, because if you're going to build the whole dash, which is what I'm almost finished with now, then you want everything on the dash done, so that you can close that chapter and think about the shell when it's coming back soon, you know. So these jobs, I didn't want to get the car back without having done this, because what happens is it won't get done. You'll just clip the blank fascia on, and I'll be one of them jobs, oh, I'll have to do that one day. Now, get it out of the way, get it done while you've got a chance. That's why. Okay. Make sure you get some of this epoxy in your toolkit. 2-part, better. It's like Araldite, but a lot better than Araldite. I'll show you the tubs in a minute, and you can get yourself some. You won't regret it, I'm telling you. So, loading up these LEDs. Don't worry that it's going to create a dome, because we just sand that back. That gives it a matte finish, more diffused light, because remember, we don't want it too bright. Just want a diffused light. So we've got those there. I think that's all of them in. I think it is. There's that little stud there. I may as well just flush fit that. There's a little mounting stud which I fitted, just a recessed stud there for attaching the cable to. That's it. I mixed too much then. It's a shame to waste that, because that's blooming good stuff. About to show you the bottles. We'll zoom out. I'll stay on with me, may as well. No point going anywhere. I'll rush back on the chair. 2 secs, please. Grabbing the bottles and bring them to you now. Okay, look. Deluxe material. Speed epoxy 2. High strength, rapid setting, sets clear. Sandable, sets hard, mix ratio 1:1. It's beautiful. I got this from CPC Farnell. Go online, CPC Farnell, Farnell, and type in to their website speed epoxy, and you won't be disappointed with this. Other epoxies are out there, but you get a lot of bang for your buck with this. Look at these bottles, a total of, well, yeah, it's a total, because you add the two together to give us the total amount. Oh, what mil have we got? On the box, do we have the mil, everybody? 224 grams. Okay. That's all we get, 224 grams. Is it a 100ml bottle? A Coca-Cola can's 330. Is there 3 of them in a Coke can? 1.5 probably. 150ml bottles then, maybe. 175. It's irrelevant. Speed epoxy. 1-on-1 mix. Keep your lids on the top. Store it. Needs to be room temperature used. Don't use it cold. Room temp, please. So 20 degrees works better. When it's cold, it starts getting too, the viscosity gets too thick. I just rate it. Set's clear, but I think you can get one that's coloured. But as I say about it, CPC Farnell will get you onto the site. That's the place where I buy it. I've not seen it in any other shops, but then I haven't looked. It could be on eBay. We can try that. However, 4 minutes and it begins to, in fact, this has been 5 minutes. So maybe not 4. Oh yeah, it is starting to gel. That's gel in there, look. Might not be 4 minutes, you know. But it is. It's good, because there's nothing worse than waiting. You want to get on with a job. There it's going now, look. You want to get on with a job, you don't want a blob. You want it set and done. Look, it's going. Exactly what it says on the tin. It means that you can do things, get onto other jobs. That tanky stuff that I've been using, scroll back through the last tech vid, It's a very hard black resin. There'll be an application for that. I think that, you know, for what it costs, what we can get with these, it's crazy. I think the Bedanki was 12 quid. I actually don't know how much that was, so that's not really a valid statement at this point in time, but the Bedanki takes forever to cure. Rock! Like rock when it is, probably harder than this stuff. But I've been using it like where I could have used this and saved the cash, but there'll be an application for pack. I'm never going to say it, and whoever made that is bugging up, because all you're going to do is like recommend it to make. Do you want to get some of this resin to Patak's blooming sauce? I don't know, you know. So anyway, we digress. The LEDs will soon be ready. I promised you that I'd find some coloured decals to fit in it, because it'd be horrible to leave you on this clip of the episode 34 without showing you this completed. So we will do that. So I'll be right back when this is cured. Nice. Very nice. My T-shifter's on the floor at the moment, but I've just finished the wiring harness for that. Just checking everything's okay. I've slightly improved the micro switch. I did have a little button type micro switch on this, but I've changed it for a roller type, just a lot smoother. I found it, I didn't know I had it. I thought, that's nice. That roller switch will work better. So it's just located in the end. The lights will probably dazzle you. Just at the edge there, there's a little roller micro switch which works better. We've got to build a couple little lighting shields for this, and also we've got to build the bristles or the rubber slit which hides the internal workings. They're always aged, and they're always, you find them and they're always cracked and perished. So we could get like a draft excluder brush edge and make one of them bristle type enclosures. They're much better. With me increasing the light in here, we're going to get some light bleed through. Even with a good original new old stock rubber, you probably get some. But we've got a little shield bracket to put on. But the illumination on this works really good, so I'm going to stick with that, even though it's probably a little bit bright, but I can just dim it down. So that's just a work in progress, but it's done and on its multi-harness and tested. Up on the bench we go. Accelerator pedal needed a micro switch on it. I'll just grab the micro switch, not on the tripod, apologies here. I'll try and keep this framed. Micro switch on a sort of sliding bracket. It's just a bracket that I found. I don't know what it's off. I think it actually got mixed up into my tub of galvanizing bits, and this is someone else's bracket. There was loads of them, and it must have been like mass produced, something they were doing in the dippers. One of them's in the dippers, in the galvanizers, one of them slipped into the box quite handily. So using a bracket, again another sliding bracket on top of that oval hole, we're able to set the accelerator kickdown switch exactly where we need it. We've got enough adjustment there. So that's the accelerator kickdown switch, or one that could be used, but you could have any bracket attaching to this plate and make whatever you want. But that seems to work. Not much different than the Ford's one that they had on the cable. And then over to the brake pedal box. Needs the switch for the cruise control vacuum mechanical switch itself. That's that one. I don't think we've ever shown this before. It's also the electrical switch as well, which breaks the cruise out. The cruise actually activates off both of these, or deactivates off both of these. It can pick up a loading on the lamps, and it also checks that your light bulbs are present. I've mentioned this before. Cruise won't work if you haven't got your filament bulbs connected, or a loading equivalent to that. If you change your lamps on a car with cruise control to LEDs, you may well find your cruise doesn't work, because it looks for a resistance path through to ground via the filament of the bulb. For some reason, cruise does not work when brake lights aren't working. It's just an extra safety feature. So that would pick up off that, and you could just run it just off that as the kill switch for the cruise. Had to take a phone call. The office is in the workshop. Sorry about that. Mechanically operated. So the vacuum is reliant upon this port in here being shut. So as soon as you hit your brake, it actually opens that valve and dumps the vacuum out. So the cruise has got an extra level of safety as well, and also 2 electrical contacts as well that also kill the cruise. So 3 items there knocking the cruise out, as well as the speed sensor. When you drop speed, it knocks it out. So, and also it has to be in drive, so plenty of coverage. So we're going to strip this pedal box down now and take the parts to be powder coated. I didn't get these powder coated because I hadn't developed the switch in brackets. I didn't want them powder coated until I'd welded the brackets on. So I've welded the brackets on, and they're ready now to go to powder coat, which would close that chapter and pretty much close the cruise control chapter, other than the bracket on the Weber carburetor, the end of the cable of the cruise. But that's dead easy to do. I just copy what I've done on Ruby because that's up and running. So really we're all done there, and we're now starting to close up the electrical department really, and start to just, now we can wire tie everything up into straight lines across here and then move into the harness for the engine bay. There's actually not much to do in the engine bay compared to all the modules that we had to build for this. So that's that done. We just need to move down. So again, I'll put a lot of stuff that I'm not going to use anymore out of the way, so we've got more operating space, and then we're done there. There is a possibility of building one more module, you know what I'm like with my modules. Coming up in my left hand and taking you under the light of the workbench lamp magnifier. Here we have a map sensor. Okay, map maximum. Oh no, what's it stand for? Oh my god, I forgot. Absolute. Oh, sorry. Yeah. We're on. Manifold absolute pressure, or manifold air pressure. Manifold air pressure, or manifold absolute pressure. I think it's manifold air pressure. It's off a Granada. Okay. And I didn't know what it was, but when I stripped the Granada, I took everything off that looked interesting. This looked interesting. Why would they have this, we wondered. Anyway, I've done some research on it, and I've got a book. I'll take you across to the book. I think you've seen this book before. This is actually Scorpio Granada book, but it tells you all the schematics for electrics. It's been handy for reference for a few things, and it shows it in there as the map sensor, and it connects to straight through to the engine computer. Only 3 wires on it: ground, 12, and then an output wire. So if we connect it to the scope or to a voltmeter, we'll be able to see what this does. Now I'm going to make a guess. I think you'd probably be with me on this, that if you suck on this tube, thereby emulating the pressure of a inlet manifold, or obviously you're not going to get the same barometric pressure or whatever it's measured in HGs, I'm not quite sure, but suck on the tube and would expect the output to either switch, although it's going into the computer, it's going to probably send out data, signals, or just a pure voltage. So the first thing we'll do is we'll see if it sends out a varying voltage, and then the computer then interprets that, or whether they've put more electronics in here to make it actually send out a signal. We'll have to have a look, but that's what the scope's handy for. Oscilloscope just to the left, and that's good for checking what electronic items are doing, what kind of outputs they're giving. You can get the scope up and it'll tell us all sorts. That'd be interesting. Now, the reason I was looking at it is because I did some research over. You go to look at the gearbox as I chat to you. The gearbox, as we know, has the torque converter lockup on it, and we've built the torque converter speed activated lockup, so lockup comes in around the 45 to 50 mile an hour mark. It doesn't want to be locked up at lower speeds than that, unless it's a special application like towing a caravan up a hill, where I've read that you can have an override switch. If in certain circumstances is beneficial to lock the converter for towing applications. The exact science of that I'm still researching. It's to do with not overheating, it's to do with slippage in the torque converter. Locking the torque converter reduces slippage, and may be that when you're towing that's an advantage. I'm sure that it is. However, whilst I was researching that, I found that the cruise really wants to be on near speed when the engine and drivetrain are all run almost in harmony together, as opposed to if you're revving the engine. So it looks like you wouldn't have the lockup on if you're racing the car. But that might again be open for interpretation. However, what I did read is a lot of lockups have a vac switch set to a particular point so that when the loading's just right on the engine, the torque converter's happy to lock. So if I was to push my foot down to the floor on the motorway at 70, it looks like they want you to knock the lockup off for the period that the engine's under loading. I would presume this is to help it drop a gear smoothly without the lockup being on, because there would be harsh changes perhaps with the lockup always on. So drop a gear smoothly. Then once the loading on the engine becomes more evened out and you're coasting or you're cruising again, it would then re-engage the lockup converter. So when engine conditions and drivetrain are very harmonious or in harmony, it looks like that's the time to activate the lockup. For that reason, we'd need to know when the engine was under load, and you can get a basic adjustable vacuum switch which would fit on one of the vac lines. We've got a vac line coming into the box for the change modulator on the side of the box to change gears. The gearbox uses the vac sensor or vac pressure from the manifold of the Pinto engine, activates a little valve. I'm going to slowly take you across to that valve and show you the valve. This helps with smooth gear changes, this valve, because it determines where my foot is on the gas and the engine loading, up a hill, down a hill, etc. There it is. So with a little bit of research, we find that vacuum pressure varies under certain conditions of driving, and indeed that will be why you can get those dash mounted old school vacuum gauges that show you some form of economy. Smiths used to do one, if you remember, green, orange, yellow sort of banding dial face on it, small little Smiths gauge. I used to have one on my Escort van. So vacuum is varying under different conditions, and they've used this they've used this sort of effect to change the gears with this modulator. So that's a vacuum diaphragm. As I decelerate or let my foot off the gas, the vacuum increases because the throttle's closing and there's more vacuum available on tap, and moves a pin in here which opens various valves in this, and that's another science, but that tells it when to up or down shift. So as well as that, we would also use the same, we'd tee off that piece of vac and connect in perhaps this little device, and we could build, if depending on what output it gives, we could build a module that's adjustable so that I could then have the adjuster in the car to set this up to get this going right. So we could have it dangling down or on the center console on a plug, and to build a module that's variable, and then find the ideal cruising position and throttle position where you think, right, that's good for lockup. Then turn my adjuster, if I build this, and get it to lock the converter on as long as the other conditions are satisfied. We talked about these on one of the earlier films, whereby we built this speed control. Here it is coming over to the bench. This won't let the lockup come on unless we're over 45 miles an hour, that's all that does. And also there's an accelerator pedal switch, sorry, a brake pedal switch, which if I'm braking also disengages the lockup. So lockup won't come on if your foot's on the brake, it won't come on unless you're over 45 miles an hour with this. And now we're saying perhaps it won't come on unless the vacuum conditions under certain conditions, you know, like coasting position that we talked about. So if we don't build it and get it running today on this part of the video, we need to allow a wire for it. Now there's no more cables left in the multi-harness connector, and I would like to fit, if I'm going to do a vac switch, I'd like it on the gearbox. If it's a mechanical vac switch I end up buying, I'm going to fit it higher up so I can get to it in the engine bay. I don't want to be crawling under the car to adjust it. If it's an electronic one, like that one I just showed you on the bench there, that map sensor, we could fit it on the side of the engine out of the way, then just have a separate harness, only 3 wires. In fact, it wouldn't need it's crazy really, because it could pick the 12 volts up off. I've already got 12 on board here, I've already got ground on board here. It's a shame there's not one more cable, because I could have brought that extra cable up, but the multi-plug I don't think's got enough. I don't think there was a spare on this. If I recall, I've used all these cables. Don't think there's a spare one. That's a shame. Anyway, we'd have to have an extra multi-plug on there. And probably if I'm going to put an extra plug on it, I'd just do all 3 wires, ground, 12, and the output of it, and bring it on. So when you did take the gearbox out, you'd now disconnect 2 looms, but it'd only be an extra 3 wire loom. I don't think that'd be a big deal. And then you just tag it along this loom. We've not wrapped this yet, so you could tag it into the loom so that it breaks out here on a separate plug. So you still have 1 cord, if you will, but 2 connector plugs here. And then we could fit the sensor on the gearbox out of the way. We don't want to, because we don't want things to be seen in the engine bay, because we're trying to make the car, whilst I know it's not original, but I'm trying to make it look like, when you look under the engine bay, it's not absolutely overrun with all my extras. It's just like, if you look from there, you can just say, oh yeah, I see an extra cable or whatever, but it looks like a 71 factory engine bay. Concourse judge, of course, is going to say, I can spot an extra throttle linkage for your cruise, and I'm not bothered about that. But when you look, as a quick glance into the engine bay, I don't want loads of extra harnesses on show, I'm trying to hide everything. So for that reason, I would put the sensor in there. So here it is. Let's just offer it up and see. Look, over we go, and let's just see. We could bolt this to this somewhere around there. Somewhere around here, I'm sure we could find a place to nestle that in, and then we would have a sensor telling us the vac, which could be handy. Could be overkill, could be too much info that we don't need, I don't know, but depending on its output, we just don't know what this map sensor gives out. You know, I haven't got a vac pump. I don't fancy sucking on this all day, but I could use the vac pump off the cruise control perhaps, or I could use to sort of trying to think of a way you could do it. There'll be a way. Anyhow, I think what I'll do is a bit of fun, as long as I'm ahead of schedule and I get this stuff off to the powder coaters now, and I have a quick tidy up and a re-evaluation. If a couple of hours appears, I'm going to have a little play around with this sensor, because I'm very curious and I like hobbying stuff, and I like mods, and I like custom things, and it's only 3 cables, so wouldn't it be nice just to have vacuum information on hand? You could even build an economy gauge with it, because if we can decode this info, I could have a little miniature economy gauge showing me the engine vacuum pressure. It'd be quite handy to have. I think I'm going to do it. Do you want to vote in the chat box there? We're going to get involved in this with time's on our side, as Rod Stewart said in the Young Turks song. Let's see what we can do. Stay with me. Patrons, YouTubers, just stay on board. Okay, it's fun time. Well, yeah, we talked about this device, didn't we? So we'll put it on the bench now, and this is what they call the map sensor, as just discussed. And can we use it to control our lockdown, or should we just get a normally operated adjustable vacuum switch? Probably. However, curiosity. Oof. Do we really want to see what output it gives? I've no idea, so you're just going to join me. I know that it's 12 volts. I'll watch these two don't short out. I've just quickly connected 12. This will pan you down just a little bit of a 1-2. Buckle my shoe, hands only. You need to see my ugly mug on screen. Take away the signal projector, we don't need that. Or a signal injector, or a signal generator, SWG, square wave generator. Away we go with that. Don't need that. What we do need is the input to the oscilloscope. So our friend the scope is back in town. I'll take the lights off the screen of the scope. Actually, tilt that out of the way. What? It squeaks because it's drilled into a piece of wood. There's my super duper lens, by the way. I've dropped that and broke it. That's off a projector out of a pub. 3 screen CRT projector. Scrapped, but kept the lenses. Great little magnifying glasses, but fell on the floor. So 12 volts. We know the wires on the map sensor because I checked it up in the schematic. So we've got 12 volts to it, and this is the output wire. Now, as I said, when we're talking about the gearbox and the lock-up change positions, if you can interpret the signal out of this, you could use it to control a lock-up. But if it's got no other purpose other than that, and it's overkill, because this is probably capable of doing much more, I'd imagine, in a unit that's sealed. We can't take it apart because it's resin sealed, so we can't even look what's inside this. If you want to get a code for it and Google it yourself if you're interested, it is part number, it's on an E7EF-9F479-A2A. If you type that in, I'll read it back again because a lot of people like this kind of stuff, Googling it. Echo 7 Echo Foxtrot -9 Foxtrot. Looks like 1 7. Can't tell. 179-A2A. I think that's it. So we want to see what output the scope reads, if indeed any at all, because who knows. So ground the scope to the same ground as this. Hook the scope on. And absolutely nothing. Dead. Flatline. Oh, try connecting your 12 volts up to it. Oh, we're in. We've got a signal. The 12 volts wire come off. Why don't you just get your croc clips fixed, you idiot? We've got ourselves an output from the map square wave. Look. Looks like it is, hang on. Oh yeah, it's rock steady square wave there. Lighter waves, please, bugger off. A rock steady square wave is coming straight out of this map sensor. The heart in this is still beating. You know, I mean, you just throw it in the bin, you wouldn't know what it was. That's some kind of, so in theory, I'm excited. I love stuff like this. So, do we suck on the tube, and what does it do? I would guess, and I promise you, I have no idea. I would guess it'll change the square wave. Because if that was a data stream, right, you wouldn't have one wire on it. It'd be like a TX RX wire. It'd be like shielded, or this has to be the output similar to a speed sensor. Just because it's on one single unshielded cable, it's just going to be 5 volt pulses. That's what I kind of like guessed based upon the cabling of the map that it might be. But I didn't think it'd be a cleaner signal as this. On the tube. Yep, it's stretching. Let's bring you in. In fact, we can zoom you in so you can see a bit better when I draw vacuum on the tube. Now, for you, I can see in the screen that that's scrolling across. Let me just see if I can lock you on better at that frequency, because what happens is the camera's shutter speed may or may not interface with the way that this displays. You've got sort of 50 Hertz on here, you've got your shutter speed, etc. Draw on the tube, blow into this tube. You can just see it changing shape. Okay, let's try and get her back on. On the shoulder. Go. Whoop. Yeah, doesn't change by much though. So we're talking about we can count the frequency that it's running at. Don't worry about the volts per division. We can actually calculate that out by just positioning this in the screen somewhere where we can measure it. So just bring it across and we count using the graph on screen here and dividing it out. Time division is 1 millisecond is each square. So this is how you can calculate the frequency. So we could calculate, it's looking like, based upon this, it's looking like it's around the 120 Hertz range, around that area. Just going to make a quick guess on that, on volts division. oh, milliseconds division, sorry, 0.1 milliseconds, there's 0.1 of a second there, we'll never get it off that. So hertz wise, looks like around the 120, then changing to, not a very lot, it drops frequency as a draw on it, so that goes down to say 90, 100, 90 and 100, and I'm drawing on this pretty hard. Let's bring it back out. Yeah, I'm taking. I think that's about as much as I can get. Whoa. So, right, I'm just messing about. I'm sorry. We have it. We'd have to work out the HGs on a car's inlet. Is it between 0 and 30 HG? Can't remember. I think so. So this probably varies between 0 and 30. I can't draw or suck 30G, so we don't really know its operating range, but it looks like it's going to be like probably 70 to 120 hertz operating range. So you would need to get a sensor that would read that. I've lost the signal. Oh, that's just because the earth's come off. There it is. You need a sensor to read that. It's overkill. I'm going to have to build another box for it, and all it's ever going to be doing in my car is controlling the lockup zone. So all really we need to do, we don't want to use this. It was an interesting experiment to show the curiosity, but we're just going to get an off-the-shelf vac switch that operates at around, I don't know, I think you would want it to be about between 6 and 10 HGs based on what I googled. So that switch will be found, and then we'll just have to add 2 more wires. So we do definitely want to add, I've done more research as well on torque converter lockups, and everything that we've done so far on the lockup is good and correct. Brake pedal operation, brake delay, torque delay when it cuts out, lockup delay when it cuts out on the brake pedal, so you don't get chatter. But what we haven't got is the loading of the engine, the fact that you need to disengage the lockup when the engine responds, so it's under load so that it can drop its gear. If you're going uphill in overdrive and you put your foot down, the engine's now loading, the vac sensor on the engine throttle, the valve, the changeover valve at the side of the engine, the gearbox, sorry, will pull in because you're loading the engine, vac increases, vac decreases, vac decreases, and the armature, the locking pin on the side of the coil, oh god, I'm cracking up, not the coil, the vacuum modulator was the word, long day. Side of the modulator moves, changes the gear, but if the lockup is still engaged, the gear change will be harsh because you've not got the cushioning effect. So we do need to have a disengagement upon engine load situation going on, and that's where the vac switch will come in. Yes, could have done it electronically, but it's overkill really, it's overcomplicating things by adding a switch box to this. Could just build one up, but I can't seem to, I'm not going to know the range. It's easier just to get an adjustable vac switch off the shelf, already done, tried and tested technology, bolt it on 2 wires, so we just need to add an extra 2 interrupt cables into that loom. Good job that we've not wrapped it yet, to include the option for that switch, and perhaps route the cables down into that loom now while we've got the chance. Okay, it'll have a separate multi-plug, but that doesn't matter. 2 plugs on the gearbox ain't no much difference than one. So we'll add in a loom to the gearbox, we're fitting a vac switch on the side of the box, teeing into the manifold vacuum, which is great. As long as you're on ported vacuum as well, I found that's the vac point, not on the intake of the carb, but on the other side of the valves of the carb, of the butterfly valves of the carb, what's called ported vacuum, which is what the modulator's controlled off anyway. So that solves that. That took a little bit of research, and Ruby hasn't got this feature. Ruby's torque comes on only with the cruise control, which gives you again a lot of the lockout features that I've got on this one, i.e. the brake pedal disengagement of cruise disengages the lockup. However, Ruby does not disengage the lockup when the cruise drops a gear, and the cruise can very rarely drop a gear when it's cruising uphill. It will knock down the kickdown, so you would get that harsh change. So that wants modifying. We need to add this switch to Project Ruby as well. But that's all a great thing about learning. That's the great thing about doing the projects, because you learn as you go along, and the knowledge is great, and it's here to share on YouTube, which is good fun. I like doing that. These pieces of kit we don't need now, we can switch off. We can now, I think I just showed you, just going to reach across and grab it. Hopefully this was just on the previous clip a few minutes ago. We've got our brackets in, there's our vac switch there for the cruise control, and our pins. Our brackets are in, ready to be powder coated. Just need to strip these. I think I've already covered stripping these down, but I'll do it anyway. I'm going to do that tomorrow, so I'm going to wrap for this evening. So tonight's job is a clear of the bench. Some of this stuff's now becoming redundant. We're going to start closing down the electronics department because it's done its electronics job. You know, that's been done. All of this is really going to be surplus to requirements for the build, and what's going to be critical is getting in as much space as we can to have the body shell here and to not be restricted on space. So this desk would have to go to create a hell of a lot more side room. When the car comes in, it's going to be on its dolly, it's going to be on its dolly wheels. We'll be able to push it slightly. We must remember as well to pad the wall so that if I push the car it doesn't roll and hit the side of the wall, because now it's going to be susceptible to moving and hitting things when it's on them caster wheels. Car's a while off coming back yet, but we've got an engine to build. We've got the suspension front cradle to finish off, a few little tweaks to do to that. Gearbox is done, of course. Dashboard needs now tying up all them harnesses, and then we work our way into the engine bay harness. But there are no modules in there. It's simply a case of wire wrapping and neatening up, and there's a couple of additional cables that need to go in. But other than that, that harness doesn't require the hardcore electronics bench to be built. So that's probably my next job, engine bay loom, but to be starting to think ahead. Again, there's some extra things in there's some 4 center clocks to do. They just want the innards putting in. Here they are. Over here, these need building up. They need center pods, fuel gauge, temperature gauge, amp gauge, and oil pressure gauge one fitting in, and then testing into the wiring harness warning lamps. But it's all coming to a close here now on this electronics build. It's been a great ride. I've enjoyed it. I really have enjoyed it. Learnt a little bit as well. Always increase your knowledge of electronics. I don't know it all. Nice to learn a few little tips. Learn a few little workarounds on the 555 I didn't know you could do. Worked with that 4017 decade counter. Worked with those Darlington arrays. Worked with those 2917. What do they call those 2917s? They're the not the op-amp chips. Name for those pulse counters. Chip. Great little chip. Learned as we've gone along. It's been a great month on the electronics. It's time now to close the electronics department up quite soon. Before we do, we'll do that harness. Okay, we'll catch you in a sec for some other clip. Not sure what we're going to be on with, probably the center clocks. See you in a sec. Okay, it's gauge refurb time. Join us as we start to put together all the gauges that I can find to discover the best in the bunch. Now, Bramble's gauges. I hope you can still hear me. I'm drifting from the mic. I'm sorry about that, but we've got a wireless mic on the way. We're definitely mixing our words up today. We've definitely got brain damage. So there's a tray there. I've just introduced it to you. Gonna flip the screen. Round we go, down and we wheel ourselves in. Squeaky as we go. Wheeling ourselves into shot for you. Loads and loads of gauges. Okay, for us to pick from. Brambles are in here somewhere because I've stripped Brambles clocks down when they got sent away to get re-chromed, if you recall. So they're in there somewhere in here. They've got mixed up. They've got a little letter and a marking on the side of which ones were brambles. In fact, some of them are over there. I found them. There they go. So all I'm going to do is go through the best pick of the bunch of gauges, and we'll start rebuilding them. Now we've got, well, this isn't brambles by the way. We've got there's actually three types of centre console. Would you believe? Do you want to go on a little bit of train spotting stuff now? Because I know you lot like learning. Even if you've not got Cortinas, I can, from what I read and what you tell me, you just like learning, which is good. It's what we like to do. Three types of centre gauge, centre pod, not Santa pod, but centre pod. Three types used. An original one, this is a mid-range one here. I'm seeing if I can find an original dial face for you. And it's all to do with the size of the gauges. We haven't got the Mark 1 version here. Let's see if we have. Must be in here. I'm looking for a conical shaped lens. Dash lamps. Yeah, conical shaped lens in here somewhere. We will have. Rusty. A lot of rusty dials, folks. Brambles ones were pretty rusted up. If I haven't got a... Yes, there's a conical. Okay, I've got one to show you now. Three types. Two types of plastic. This one in my right hand. Although for you, curiously, it shows it in my left hand on the screen. I don't know what the hell's going on. Oh well, the screen seems to be inverted. Two types. Both early two types use the same plastic surround, but conical lens was used at first. So a Madonna nipple on the end, or a 60s bra on the end. Remember them cone-shaped bras from the 60s? The girls we all grew up and love. Nice fashions. Not like today. Right, so those conical bra type, what am I talking about? Conical lens was used initially. Then, for some reason, they got rid of the conical lens, but kept the housing, then went flat lens. So these are flat lenses inside there. Then, after that, on the 72 cars, they got rid of that altogether and then made the openings even larger, or the dial faces even larger. You can see that much larger and easier to read instruments than the one on the right. Big dial faces, flat lenses, with the logos themselves actually better illuminated. What they did with the logos, this is quite clever, as you probably know this with optics, you engrave something into a piece of perspex and it tends to cause internal refraction and you get a little indicator. The fuel here, look, just lightly engraved in, very subtle way of doing it. Really, you know, obviously once it's on the black it shows through, but again it's done on these flat gauges as well. It's alright, you can read them, but these ones are done where they've actually made the icon, in this case the petrol pump icon, it's actually built into an illuminated panel itself, which I prefer. This it's obviously a hell of a lot easier to read and it just looks better, but originality wise we've got to go with it's a shame, like we're going to keep the conical lenses which Bramble had. I don't know at what point they would have had the flat lenses, because Bramble was coming up to the end of where they almost became the Series 2. Bramble's like a Series 1.5. If I don't know what I mean about Series 1 and 2 Cortinas, correct me on this, because there'll be some train spotter stuff here now that I miss. But bring you in, have a chat with you. Hold on a sec, let's get you in. You can't see me. Sometimes it's better to chat and look at the same time. So up we go. Let's talk about Series 1 cars. Okay, when they came out in 70, the Cortina came out in 71, I hope. October 1970. Better check that. Oh my god. J-Reg. Okay, October 70 I think was Cortina. They had on the Series 1 cars, they had various dashboard changes, these clock changes, instrument changes were done, some changes were done to the way the dashboard was laid out with the speedo on GXLs anyway, speedo on the left, speedo on the right, that kind of thing. Speedo, rev counter and clock were swapped around, bing bing bing. They changed a few of those things, they changed this, loads of little details which we keep train spotting about. I can't think of them all off the top of my head, but by the time it got to heading up towards the end of the 72, approaching the facelift car, they'd done sort of two major changes, and Bramble falls between the two because it's got Ford Sports wheels and not Ross styles, but then sports wheels were normally put on the full Series 2 car, like my green GXL, which has these are part of the Series 2 improvements, the dash vents are part of the Series 2 improvements, and the flipping of the clocks, the rev clocks, is part of that. But Bramble's got a mixture of Series 1 bits and Series 2 bits, which would be normal because they'd have run out of Ross style wheels, probably, and then began to roll out, excuse the pun, the sports wheels. So there's lots of like little changes, and Bramble falls between a lot of these, which I found interesting. So it almost would have had these if it was on L-Reg K, just missing it. But you could see that they'd started to roll out some of the changes, and the dash vents would have been separated. They split the dash vents at the moment on these Series 1 cars. The dash vents are all one vent, and customers complain that it wouldn't direct to the face very well for fresh air, which it doesn't if you use a single one. I always take them out because it's one thing, whilst keeping it original, I cannot cope with it not directing properly at my face. And those long, straight air vents that are on the top of the dashboard above the instruments and the glove box, they don't. They're just one big flap, and the power is kind of like very. This was part of the design concept for them to do it. They just didn't want the air to be physically. They didn't want you to physically feel the air on your face with those vents. I've read this in Autocar, so I know it's come from Ford. This info out of Autocar magazine, but they just wanted to create a volume of air, which they did, and I think they increased the volume of air based upon the Mark II Cortina. This is called aeroflow, where air comes into the cabin and then exits through the apertures in the back of the car, so into your scuttle, into your heater box, through your fresh air vents, sort of half pressurising the car as the ram air goes along, then stale air removed, and the aim was to replace the interior volume of air every so many cycles a minute would be a change of air, or so many cycles an hour change of cabin air to keep it fresh. So using those vents, the idea was the long vents made it so they didn't blast on your face, and they thought that was a good thing to do, but actually people complained that that's what they wanted it to do. So to create more pressure, they made it so that the vent was split and you could close one part of it, thereby concentrating the airflow into a smaller vent, which then blasts on your face, and that's how I set mine up. These are the vents on top of the dash, by the way. Fresh air only these, they don't have hot air coming out, that's done through different ducts. These are the fresh air only vents, and they made it so they were split, and that was on Series 2 cars. Bramble has got the full vents, but I'm going to be changing them. But Bramble's got the steel wheels and a couple of dashboard changes that I noticed as well. And I'm trying to think of some other changes that it's got, which makes it Series 1.5. That's what originally I was explaining in this clip. But the air vents, I like to aim them right in my face, cold air. And the only thing is, when you've got your full cold air on Cortinas, is you can't have hot air to your feet and cold air to your face. You can, but you can't have it blasting full power. So you can tweak the heater box so that when you put the fresh air vent on, it shuts all the other flaps down to create the maximum flow to your face. You can tweak the flap so that it leaves a little bit of hot air on the flap that warms your feet when you're getting full air I'll talk about that when I build the heater box. That's just a little thing that I've noticed. Back to this then, that was a bramble rumble. You've got these different things that light up in different ways. We've got to make it back to conical, but with all nice gauge faces. Now the good thing is that a lot of these later gauges seem to survive better, don't rust as bad. Now the only thing that we wanted to establish is, can we pinch these face plates off these gauges and retrofit them with the conical lenses, and thereby giving Bramble a nice set of non-rusted up gauges, because Bramble's gauge faces have rusted. I'll show you one. They're wrapped in cling film bubble wrap so that we knew, and they're marked with a little marking on the back so we knew what car they were out of. Oh sorry, I've already took them out. Here we go. So here we go for a... You see, I can't really, too much had got to it. Okay. Now, there's not a lot I can do there. Over decal it, you could make a decal, a vinyl decal. But when you're sat on absolute ton of spares, you've got to say to yourself, why did I accumulate all these spares if I'm never going to use them? Why am I making life harder for myself? It's not like I haven't got any other option. And in which case then you start touching in the face, but you're just wasting time. You're wasting the fact that you've accumulated your parts in the first place. Or you're trying to prove what? That it's Bramble's original dial face? Are you really going to be worried about that? Or are you just going to waste time? You know, so you've got, these are difficult questions, because will it niggle me knowing that that's not Bramble's gauge? Probably will. It probably will. It probably niggle me, I'm thinking. So I tell you what I'll do to compromise, right? This is how I'm going to do it. I'm going to use Bramble's back plate, the casing, the dial face, but not, sorry, not the dial face, the dial cover and the conical lens, but not the dial face. So I'm going to use as much as I can, but I'm not repairing that dial face when I've got good ones. As long as, and it's only under this condition, and we're going to do this, folks, that the font and the layout of the gauge is the same type that Bramble had on the facelift gauge. So now we can ask ourselves, did they change it? This isn't a fuel gauge, this is a temp gauge. If I just call that fuel gauge, did they change the font faces, the font, the design, the way that the gauge was printed? This is, I don't know, we're about to find out. Here's a fuel gauge, 71 fuel gauge. I mean, you know, we were struggling, weren't we, there? It just gets into it, the damp just got into it. In fact, the back of the centre clocks had brambles actually inside them. I remember them attacking. The gauges still worked. So, that's fuel. Let's have a look. That's a facelift, Series 2, large face style, and that's Series 1. Now then, there's a dramatic change. Have we got a part number change? Hold on, let's see. We've got a part number change. Time for the magnifying lens. Okay, I'm getting 71 BB, 9305. I'm getting 9305, 71 BB. Exactly the same part number. So all they've done then, folks, is they've just changed the housing of this. They've made it larger because customers complained that the conical ones, I should have mentioned this before, customers complained this was just unreadable, and yes, it is unreadable. Even these are really unreadable, but these are really, really unreadable. Ask me, I drive these cars. But yes, I can fit this in and make my life easier. I'm not going to do that, so I'm going to make my life hard, because that's what it is. It's Cortina, isn't it? Okay, they haven't changed the dial face, they've just changed the casing. So that's good news for us, because we can now pinch this out of there and fit it into there. What we'll do, we'll clean this. It's not damaged, that. Look, it's not melted. The bulbs normally melt these, or quite often will melt these. I'll show you a melted one. That's not a melted one. Here's a melted one. Hold on, reaching across. Here's a melted one. See what the heat of the bulb does to them and writes them off. It's one way you can, you see the thing is that people put the wrong bulbs in there. I mean, even with the right bulbs in there, they still used to sort of get a bit brittle. But with the wrong bulb in, that's because of the wrong bulb. Because there's different wattages of those wedge bulbs. The little wedge bulbs that you can fit in these different wattages. People put the wrong ones in and cut the gauge. With LEDs, this doesn't matter. We can make these gauges light up like Blackpool illuminations, no problem. Absolutely, going to be blooming marvellous. These LEDs. I'm going to go off on tangent now. Hold on, get this. This is going to look like Blackpool. It's going to be really good. Is this with these LED lamps as we drifted it out of steel, bloody great big steel girders, and then we'll weld them together with great big steel girders. Right, so we know this. All we've got to do is find 4 lovely faces, transplant all the good bits across, then add our special little feature, which you remember we did, was the sensor which we fit into the gauge to tell us when our fuel warning lamps can come on and our over temperature trip can come on. That one's melted. That's what we've got to do. So all in all, good news just means let me play, let me lay out a lovely arrangement, and we'll build 4 nice clocks for you, and then we'll fit our little sensors inside them, which we've already got built. We just need transplanting across. That's indeed if the ones I've already built have got good dial faces. They may well have, can't remember. They were trial pieces that I had. They're around somewhere. Going to do all that and lay all this out. A few minutes for me. No, a few minutes for you. Hours and hours for me. I'll take a break and have some tea. See you in a sec. An update for you. There are some different dial faces, everyone. Spotting some different ones here now. Different fuel gauge face there. So there are different ones. So our theory that they're all the same is incorrect. So scrub out everything I just said, because there are some different dial faces built here. It looks like, I'm just trying to get waiting confirmation on this, but it looks like the part numbers are the same. It's just that they've changed the design. Yes, they have to accommodate. Sorry, I'm learning. I don't know. I forget. I try, but I forget. And I'd never want to be. I'd never want to know everything either. I want to be wrong. Otherwise, I'm a smart arse. I don't want to be a smart arse. I like to know things. Yeah, it's nice to get stuff right, but people just can't wait to put you right when you're wrong. So you'd rather be wrong first. Look, the whole thing's designed differently. Okay, so you know, would I remember this? I don't think I've ever took pre-facelift Series 2 gauges apart anyway. They've always been Series 1s mine. Yeah, the way that they do it's going to dictate that face is slightly different. So that scrubs the idea about pinching these, and don't think you can substitute an old school one. Oh yeah, they go in, but you get your font wrong then, see? So we need to decide what to do about this. I think they've done this to get more light in there. I mean, that's a total redesign. That's a total gauge. This is a total amp gauge redesign. Look. So, if when this video plays back now, I upload and I'm going that there's no difference between them, someone will be, yeah, there is, yeah, there is. You were right. So I do apologise. They've changed it. So them gauges that were screwed into that Series 2 housing were actually Series 1 gauges. I must have just screwed them in there. Never mind. So we do have, and that's a very nice unit, but it's Series 2. So we're going to just save this safely somewhere, and we've just got to hunt down then, in this case, Series 1 good dial faces, and hopefully we've acquired enough stuff over the years to find what we need. I'm sure we will. Just thought I'd update you because I thought, well, someone's going to have me for that one. Okay, see you in a sec. Folks, looks like the oil is the same. So series 2 and series 1 oil gauge looks to me to be the same. I can't spot another oil gauge, or can I? There's another one. I'm just trying to see if which gauge is actually altered and which don't. The amps change. You get a larger plus and minus on the amps. So that's definitely different. That's definitely different. The fuel changes. You get different segregation marks there. The normal fuel and the old school fuel. Oh, here's the oil. The oil does change. The whole lot changes. It's a complete face redesign. That is series 2. That is series 1. What we have here on our hands that's confusing us is that we have some very clean series 1 casings and gauges that just look too good to be true, but are almost like brand new. These must have been something I acquired. Series 1, shame that needle's bent, but we can fix this. That's a nice one. That's got a sheen to it. I'm twisting that now and seeing that sheen. You can just see it there as well. Look how clean that face is. That's not tarnished or anything. In fact, looks too good to be true. That is near mint condition gauge, which I'm going to go for. I'm just going to repair the damaged needle on it. That's easily done. We can hook them out and get the needle straightened and hook it back in. So it is true, and I am wrong. I am a load of old rubbish. Every gauge on the Series 2 larger pod, uses a different face for its readout. Temperature and battery on this one are still intact. The amps on this one. It could well be that these gauges here have been screwed to this and aren't the right ones for storage reasons. That's quite possible, because I'm just looking as to why that hasn't got the different amp gauge on it. This one's got old school amp gauge, but it's in a facelift, a Series 2 casing, and that's really what it should have in it. Okay, let's look at the different logo on that. Can you see that? Do you want a torch? Hold on. Off screen, gets the torch. So you can just see, that's going to reflect, isn't it? I'm trying to show you this logo. Ain't going to work, I don't think. There, I think you've got it there, haven't you? Look at that. Now I'd say that's in the large aperture Series 2 casing, but the logo on the dial face doesn't seem to match what we're getting with these ones. So I think that this is just misleading, and what happens is, over the years I've just screwed this together with things just to keep them in one place and stop them getting lost. I don't think that they had Series 2 gauges with Series 2 gauge casings with Series 1 dialed in, although they could have done. It's possible, but it would seem to be defeating the object, because the whole point was to make the face larger. It's getting confusing, and I'm sure if I'm confused, I'm sure the hell as you are. Oh my God, I'm sorry about that. I really am. That is so train spotty. I'm in such a muddle. I don't know what's going on. There are that many different things happening here that I'm going to pick the easy route. I'm just going to get anything that looks good and screw it together, or else I'm going to be here all blooming day. Wow. Okay, overhead light on. I'm trying to give you some progress in a minute. This is mental. Nothing's happened. Okay, so back on the gauges then. We've picked the gauge we like. We're now making the paddle modification to it. If you recall, you'd have to go back on previous films, but we modify the gauges, or we upgrade them. It doesn't affect the actual viewing of the gauge. It's just we're fitting a sensor to the gauge that indicates, in this case, low fuel, and it consists of an opto beam. You can just see it. We're going to go under the light to give you a little bit better viewing experience, but you can just see where my thumb is. There's a little mini circuit board. There's two little light beams, or there's a light beam, two devices. One's an infrared emitter, one's a photo transistor or infrared receiver, and once that light beam breaks, it indicates to my control box that the fuel's low. So to break the beam, we add a paddle to the gauge needle as light as we can, In this case what we've done is a little card square and actually a wire tie, would you believe. See that bit of plastic? And what we do, put this soldering iron inside the eyelet of the gauge, which the gauge mounts on here, touching it with a pick, and the heat from the soldering iron, we push the needle into the zip tie and it creates a bond with that, and that creates a paddle fitted to the needle, and that paddle breaks the light beam, which just about fits in the gauge there, sends a signal down this cable to my little control box giving me low fuel. It's a stable system, it won't bounce because of the damping action of the needle. We've tried operational amplifier and volt comparators but not had fantastic results, although that option's still out there to improve on. So we're going to compare the two systems, see which one seems to be the best. I think this one's going to be pretty stable. I suppose there's more components involved with this one. With a voltage comparator, what it does is it measures the voltage across the battery and the voltage across the gauge, it compares them, and at a set point will trigger an output. I've used them in the past, but I found that when the voltage across the battery alters, the switching in point of the low fuel also alters. Now I have got, excuse me, now I have got an improved comparator circuit, which is supposed to be a bit more stable in that when the battery voltage drops it compensates. However, for now, as a plan B, we do this gauge. So that's exactly how I did it. Still lightweight. I've checked it for vibration, doesn't seem to affect the gauge. Gauge still deflects, so I think we'll be okay. So I'm going to refit that needle back to the gauge, and that's a good gauge face, and then we'll do one gauge at a time, and then we'll build up the 4-pod, stash the rest of the needles and gauges away. They're not needed. We'll make sure we pack them nicely. We'll put them all back together so that they're safe and that they're not exposed. We don't want them needles getting damaged, so we'll make sure they all get packed away properly and put back in the box. We've picked the fuel gauge now, and we're going to modify it. That's the old paddle I used, that was just to test the system. Chuck that now, it's not needed. This is the final assembly going back together for fuel gauge monitoring on the fuel gauge centre pod. Okay, you just saw me reassembling the gauges. I've got the temperature gauge done. I've got to say, it was a mega test of patience just to get the opto sensor just in the right position on the gauge face so that we get it to trigger just when it's approaching the red. I didn't want it to trigger in the red, but rather just when it's approaching the red. Okay, and that took some patience, a lot of patience, very fiddly, just to get the opto sensor to just slot in the right place on the dial face so that the paddle, little paddle that I fitted to the needle at the back, just clears everything. There's plenty of room. Then I glue gunned it in place, so it's locked in place now. And what happens is I apply a little bit of power to the back of the terminals for the clock, just with a 3-volt power supply or my 12-volt power supply set on 3 volts here. I should have croc leads on these, by the way. I'm very bad person for that. They've fallen off, and I'm so stupid I've not soldered them back on, so I'm holding them on with my hands. How ridiculous. Okay, well, the dash illumination is also on to test that the bulb fits in and to see how our LED illuminates the gauge, and it does it very well. There's that blue paint we keep talking about on the dash build vid. If you missed that, go back to the dash build vid where we talk about how this blue paint diffuses light and makes it easy on the eye, and that's why Ford did it, so that you wouldn't get that filament colour in your dashboard, but rather you get this sort of very nice, easy on the eye scattered light from this blue wavelength. So if you look at your optics, the nature of light, perhaps not so much optics, but the nature of light, frequency of light, you'll find that this colour that they've used, they've obviously found the best one through their research. Don't forget, Ford, we've had money to research this, and they've found that that colour, when you put the incandescent bulb against it, creates a back reflection which takes the bulb into a lovely blue hue. Works well with the LED bulb. The LED bulb's already in that spectrum anyway. and runs a lot cooler than those incandescent bulbs, so of course we'll be fitting LEDs to this. The good thing about it, I never like looking at LEDs directly, and I don't think you should either. They can hurt your eyes, but they're alright if you bounce them off an object. That way you scatter the light. So the great thing about these gauges is that they do that very nicely, and you can already see in broad daylight how that you get a lovely crescent illumination there. It's going to be beautiful at night, much better than incandescent. And I recommend sticking to as close as white as you can get. Don't buy a blue bulb for these. Let the paint do the work for you, and you'll see, look how it's lovely and colourful in there. Okay, so we've got that. We fit that over the top. I'm going to presume, I'm not really sure. Oh yeah, there's a slot in the top of it which is to light the perspex up. So that slot that's cut out is so that when I lay the perspex dial face over, or the cover, the perspex cover, in our case we're using the conical ones, the Series 1 conical Madonna's bra ones, all the 1950s, 60s lovely bras that those girls wore. Nice and classy they were in those days, not like today. With the fashion, that is. I'm not saying women, the fashions aren't as good today, and you know it. So look, that's it. Isn't it great? Now we're nice, we're not shaking the needle too much with that counterweighted paddle, as you may expect, or some people might think, well, isn't that going to shake the needle? It doesn't. It's fine. This gauge needle shakes as much as the one without the paddle fitted. So that goes on, and the LED, we don't even need to drill the back of our lovely gauge. By the way, I've cleaned it with some foam cleaner, so it's nice and clean. The wire for my little sensor just pops out of the same hole as the bulb illumination, and because it doesn't get hot, that's not going to affect that wire. And because the LEDs that are used are sort of spongy, they're kind of like a chip on board, a cob LED with like a gel coat, so it's like quite a spongy finish on the bulb. It's a long cigar shaped bulb. I'll show you. I have shown them you in previous vids again, but I'll show them you once more. So it squeezes in the wire, so we don't have to drill our gauges. So if you ever wanted to revert this back and take out the stuff that I've done, you could do that with no damage, which I like as well. So I'm confident that this is going to light up really nice. It's not dark yet, but I could turn the lights off in the unit. We'll do that now. It's a little bit ambient outside. Lux levels probably, I don't know, 0.3 lux or something like that outside. Who knows? I haven't got a lux meter here. Talking of lux, why not look? Over to the light switch we go. Back to this dial face. We'll place the perspex on. I've already tested this by applying that power to the back. As the needle swings, it breaks the light beam inside, and in this case, in the case of over temperature, the indicator stays lit, and you can see it now doing its cycle through the multifunction warning lamp. Refresh again if you don't know what this is in my hand, if you've not seen previous. I know I keep saying if you've not seen previous films. Multifunction, it's got 5 different functions, this lamp, all in one, all with different colours. None can stay on at the same time, they all cycle through sequentially so you don't get confused, with the oil and the temperature taking top priority in the stack. Indeed, the oil shares a few more pulses than, say, the Bluetooth. It's got Bluetooth, it's got black ice indicator or frost, 0 degrees. It's got over temp, it's got under fuel, and all those cycle round in this multifunction lamp, which fits in the dash just here. That way it looks original because that was an original mounting point for an indicator lamp on export cars. We believe it's for the wiper, Canadian spec wiper indicator. So that fits in there without having to drill lots of holes in the dash, and the gauge triggers it. This warning will only go out when I turn the ignition back off, so you're basically forced with that on while you're driving the car. But the idea would be it's a pull over light, so it's going to keep on going, so because your engine should not have reached that temp. It shows that something's wrong, and it saves you in time before it actually gets to a boil position, so you can monitor it, and you may reset your journey. You might find it was the fan had failed, your stats jammed shut, you're low on water, you're just a very, very hot day, a freak hot weather day, whatever it is. This will warn you of it and lock on. So it won't just do a flash once. If you weren't to catch it with your eye, this will lock on. The fuel gauge doesn't lock on. the other sensors don't lock on, just this one. So like I say, I'll go over to the lamps in the unit and turn them off. Let's have a look at this with the perspex cover on it as well, so you can see how that total internal refraction works on the logo printed or engraved into the face of the conical cover. Here we go. I think that's going to be dark enough, everyone. Camera says so. Here's the temperature conical. We don't know why they changed from conical and did away with it to a flat gauge, but we do know that they went to larger gauges on Series 2 cars because customers complained the gauges were too small. So they did what they could. Right. Yeah. You can see that this black piece of foam tape they've got just fits over there. We've got other bulbs confusing us, haven't we? So in we go. You can see the temperature is illuminated. Perhaps we'll take some of these bulbs out. It's difficult with one hand when you're filming. I don't really like taking them out, but I've just got to do it, haven't I? It's just not right. Right, take them out and stick this on here. Place the deflector and the... Can we do it? Keep your eyes on that little logo and you'll see how the temperature logo then grabs the light and picks up. As soon as I align it with that little slot, the LED lamp's able to shine through into the perspex. You can see, watch, I'll drop it down and bring it up, and you can see how the temperature logo illuminates very nicely. So that's how they did it. It's quite a clever idea. I think it's a really smart idea. Look, isn't that beautiful? Absolutely gorgeous dial there, well lit and exactly doing its job perfectly. Total internal refraction on perspex then, a beautiful gauge, nice and clean with no corrosion on that. We found some good ones. Curiously, the camera I'm using, the Panasonic HX camera, a little handheld pistol grip camera, not the best, but it got me through some scrapes. You find you have to keep your voice right next to the mic to get it. When I'm editing, sometimes your sound is a bit louder, my voice, and I have to try and adjust that in the edit. It takes a lot of time. I wish that it'd just be a constant volume, but it's just the way it's built. Curiously, I say about the camera, it's showing this as more white. I'm seeing more blue here in the real world, so the white balance on the camera there. But great, so we'll do the same treatment now with the fuel gauge, because we're really happy how this works, and we'll give these perspexes a polish up as well. A little bit of a light, very light polish with some cutting compound, some very fine, perhaps not G10, something a bit finer than G10, but we'll clean this up. Then we can assemble this, and then we can start to paint the centre clocks the right colour for the dashboard, and we'll get them all installed into that 4-pod centerpiece, the one that I've had chromed. We'll get that painted. Here we go then, another gauge to do. See you in a sec. Fuel gauge next. Okay, a little tea break and a clean up of the gauge. This is the oil pressure gauge housing. You can see where the bulb makes it go discoloured with the heat of the incandescents. As mentioned, wrong wattage equals damaged housing, and probably anyway, even with the right wattage, they'll discolour over time. We're not going to recolorise that in. Could paint that in white, but I'm not convinced the white will stick to this very well. And what I don't want is paint flaking off and showing up inside the gauge. It's not necessary. So we can put this gauge here, the oil, into this housing. So the oil's already done. A refresher for you if you missed the previous text. Little micro switch that I've soldered in position. When the oil pressure opens this, there's a name for this in gauge terms, we get a click, and that's our oil pressure lamp. So we don't have to tee off in the engine bay and have one of those ugly looking, I mean they're fine but they're just a bit bulky and ugly oil pressure switches. Made my own. Let's hope it works. It should do. Clicking out. So that goes into this housing. We'll do that now. We'll assemble it once, so then we've got the temperatures done. We'll have the oil done. We'll then move on to the amp gauge, which doesn't need any sensors on it. So we'll be good to go. Let's do it. Okay, fuel gauge going into its cleaned housing. Hey, I can't get these on. There you go. Nice and easy, does it? Let's see how that one lights up. That's another one done. We need a fuel indicator and an oil indicator. Amps, oil, fuel. There we go, they look nice and scratch free actually. Just a little, I want to buckle on my shoe. Clean these faces. They're actually not scratched, I don't need any cutting compound on those. They tend not to scratch, you never really, it's not in the area on the car these where there's any kind of like footfall or traffic or sort of hand movement or objects hitting them, so they tend to survive really well, which is good for us. The fuel. This one has got some marks, looks like a chemical of some kind on there. I don't know what that is. We'll investigate the situation on that. There's me speaking too soon, as I can see like a residue on there. We'll see if we can cut that out. If not, we'll find another. So we prep these up, and here's, for popular demand, Madonna. Now what era was that? Or wheel hubcap covers perhaps? Boob covers perhaps? Who knows? See if I can find you any 50s imagery of the girls I'm talking about. We're allowed to do this. Pan round and remember the good old days, everybody, before the PC brigade took over, and go over to the wall. In the days before the PC brigade. The very nice Agent Flux calendars of the day. Don't know what that car is. Is it a Capri? I think it is a Capri. What are you talking about? Is it a Capri? Is it a Capri? Capri is a Capri. And they were all the wives, all the workers at Adrian. You know where we want to work. Right, the rest of these. Let's do it. Okay, between jobs and getting the dial faces ready, we need a little pod gauge. It came in chrome, fully over chromed first, so we mask off. Convenient use of some paper cups there and a little bit of masking tape just to shield the ring faces. The pods have a chrome ring on, they do on this model, it's a special. So over chromed that dash pod, and then we're satin black on the inside. I'm not going to pick it up, but we're satin black on the inside, and then a special paint that just slightly bites into the chrome, and then we're off. And that's colour matched into the car body scheme. Okay, so it's the same paint code as the rest of the car parts, the rest of the dash parts should I say. Light purple brown they call it. Get you the paint code if you need it, if you're building a Ruby dash. So we carefully masked off those little trim rings there, so when the gauges pop in they have a nice little chrome bezel ring on top, similar to the way that the clocks are done on the dashboard. You'll see that's getting hydro dipped at the moment, so a couple more layers of paint to go on. Just let it go dry, 10 minutes between coats, and then we'll reveal this later on. Can't really flip you to see that inside we've also masked and done matte, because the whole thing's chromed, the plastic, vacuum metallized it's called, and then you don't want the inside of the dial faces chrome. They were always matted out. Of course Cortina Ford would have done this, but for some reason they only restricted it to just the instrument clusters. So you look at these and you think, well really they should have had the chrome surrounds on those to match the rest of the bezels. And indeed on other models of Ford vehicle, for example in America, I think cars like Mustang or Pinto, their auxiliary dials have got this on and they're colour coded in, so it's something that would have been done. It's not concourse original in terms of originality. If you were restoring the car back to exactly how it was, you would just have this overpainted completely one colour with satin on the inside of the pod. Whereas I'm just adding that little touch to it. It was done on Ruby as well, works out quite nice. We'll carry on with just dusting some layers on here. It's a matte finish, we don't want it too glossy. Okay, while that paint dries on those pods, we got ourselves the fuel sender, nicely galvanised fuel tank sender then. Little isolating rubber collar goes on the mount stud first, and then a fibre washer, and then a final washer, then this nut of unknown size. We bolt that back together, took that off to get this galvanised, left that. Now we can connect this up to the gauge and check that the gauge is calibrated, seeing that we've messed with the gauge with the paddles. Oops, caught you on the feet, sorry. Seeing that we've messed with the gauge on the paddles, we may have messed the calibration of the gauge, so we want to check that. We want to go halfway full and empty. I'm not sure if this is linear. This is a rheostat, it's a current limiting device rather than voltage. It is a variable resistance, but it's done to limit the current as opposed to the voltage in the gauge. It could be linear, that is that it's a gradual change of resistance as the float moves. If the tank's constructed parallel and there's not a sort of sculpted out bit of the tank that's got much less volume of petrol in it for the movement that you'd get, in which case this would become logarithmic. That is that it wouldn't be a gentle gradual change of the resistance here as that float moves. You would get a sudden fall up or fall down on the curve, and that's called logarithmic. So they might do it whereby they know that the last little bit of fuel in your tank, that part of the tank is sort of a small volume. In other words, it could have like a scooped out bowl shape in your tank, and this would be sat in it. You'd want it to respond differently when it gets to that area, because the gauge would still be thinking it's sort of got all that, Cortina tank's 44 litres, so if you divided it out, if the tank was 40 centimetres tall, then every 10 centimetre drop would be 10 litres. But the last bit could be shaped differently. I don't know if it is, I may be wrong. I mean, I'm not saying it is shaped differently, but if it was, then you'd alter the resistance on the last little bit of the gauge, so it would calibrate and still be level. I think that's the principle of operation. But as I said, this could be totally linear, and the tank could be parallel all the way down to the end. But we need to just check that the gauge is all right, because we've got a chance before we reassemble the pods and stuff to get the gauge. And there is a degree of calibration on the gauges. They've built them in with a little tiny fork that you insert, and you can just twist the gauge, those gauges that I've just been refurbing. Anyway, this is part of it really, so we need to get that up and running. Put that there. We'll go and see how our paint's getting on, then we'll find a nut spinner for that. Okay, here's the connector for the fuel sender. The electrical plug fits on the top of it. It's filthy. We'll do the best we can with this. It's also faded out a little bit. We'll have to live with that. Just a little bit of vinegar acid in there, cleaning that up. Diluted brick acid if you want. Make sure you neutralise it back. Some of that protecting gel we'll put in too. I don't think there's any muck in there. Seems clean. So the connector for the top of the tank, just there. We'll just put some, neutralise that back now. Some gel on that plug. Then we're ready to test. I've just metered out the gauge and it comes through 10 ohms up to 80 ohms, so it's working. So now we can hook into the loom. Comes in through the bulkhead of the cart, back in the wheel well this fits. Spare wheel tub, this goes in, grommet, the 2 plugs into the main harness, and that's it. They'll need a clean up too, so we'll clean the end connectors to it as well while we're on. And then we'll hook up and see what we get on the fuel gauge. Okay, the fuel gauge is connected into the loom and power is on into the loom. We've earthed it just there for now. Up we go. Slowly take you up and onto the bench. So we've got the float on full tank and across to the gauge. We're looking for full tank, and you can see there's 2 little calibration dots. Can you see those? 4 altogether, 2 for 0 and 2 more for a full tank. It's just between the calibration dots, just, and on the gauge itself, spin you round, showing a full tank, more or less there. You could probably tweak that tiny little bit so that second dot just comes in. You can see there the factory calibration dots go one tiny little touch, so it sits just between those dots. Now, how do I know this? I'll tell you how I know it. This gauge, unmolested, sits between the dots. The fuel tank sender in exactly the same place. Mine is a little bit out, and I've actually already adjusted it. It was way out, well, I say way out, it was well before that dot, and actually halfway between the last segment. Now I'll show you where the calibration adjustment is. I'll take it to the bench. This is going to tweak this just one little tiny little bit more. I'll show you how you do it. First we'll just see how it sits on halfway. Bear with me on this type of camera angle. It's all or nothing, I'm afraid. If I move the float to halfway, and we could all be properly set up on the bench and stuff, but I've got to work as I go. You know, this works for me. It doesn't necessarily work as a YouTube vid, although I'm sure you'll accept it. You could have all this properly lit and set up, but we're trying to do work and film. It's hard for me. So I'm going to go across. This should sit halfway between. Eventually it'll take a while to settle. It's heading that way now. We're looking for somewhere between. That's if they've calibrated it that way. The good thing is we can use the other gauge to see where we think it should be sitting. And the average, we've got 3 fuel gauges. I could take the average of them all. That doesn't show half at the moment. I know it could still probably drop a little bit more. It's going. Looks like that's where it's going to settle. And like we say, we don't know that calibrates to half. It probably does, and the gauge is overreading. We don't know yet. What I'll do now, I'll make a note of where that sits and plug the other gauge in and just see if that sits in the same place, same position on the dial face. Got to get this right. To be fair to the gauge, since I just put the camera down and it's carried on dropping, so to be fair to the gauge, I'm going to accept that's half. because that's got this last little bit that it cools down. I'd say it's half a tank, wouldn't you? We might be alright with the calibration as it is. We may be trying to be too fussy. It seems to have settled now just under, sorry, just over that centre mark in that white. I'll bring you in a little bit closer so you can see what I mean. Just over, just touching it. Now, who says that I've got the sender in exactly halfway? The true way, take 2 gauges or 3 and get the average reading. Now, what I'll do, I'll disconnect this gauge. I won't touch the sender, so we'll see where the other one parks. Here we go. So we're going to accept that it's just over the white, all right, and just under the, and just over the first calibration dot. So you would think that if I try and bring the gauge across any more, that it's going to chop out the halfway. Assuming that's correct, let's see if it is correct by getting this gauge and hooking it up. Then I'll show you the calibration screw that I used. Okay, connect this one in and see where it sits. See if it's the same as that. I'm going to take a still photo as well. Well, I must admit, it's just started to, it's gone dropped even more actually. It's just slightly touching the white now. Okay. Okay, this one just connected up and on its slow climb up to half. Will it go exactly on the white line or will it go just over it? As I said, fuel gauge sender is untouched. So far it's not stopped on half and it is going over it. It's going more than over it. This reads more than mine does. This doesn't even read half. This gauge is ahead by the same amount of clicks. It's out on those little dots, which fits the bill that the other gauge can be calibrated across now. So we'll take you across and do that, and we should get these looking the same. It's time to get a third gauge though and triple check. Here we go with a third gauge now. Okay, just to show there's no camera or trickery, our third gauge, 1, 2, and there's our modified one there with the fuel switch. So we'll see if this one, whoops, if this one sits just around where that one is. Here we go. No, that one's too unreliable. We can't use that. It's just too unreliable. We need to find another petrol gauge. Ah, here's another one. Shh, there was another one. That's okay. Tricky for me, you know. Right, here's a beaten up one though. It's well rusted, it could all be knackered. Let's try it anyway, this is fun. Away our rusty old gauge goes against the law of averages. Over the halfway. Will it land just between those two, just approaching the last bar, which is where I think they're all going to be. I haven't kicked that with my foot, have I? Hold on a sec. No, it's moved. I'm an idiot. I really am. Please stay in the same place. I'm trying to calibrate things. Can you please stop messing about? Right. Come on. Yeah, just over that dot. I think ours was the same, bar like 2 mil difference. If you remember, ours just touched it. Right, so that doesn't just touch it, and it equates to the same that we're out on those dots. So what I'm going to do, let's take you across. There you are, look. We'll calibrate you in. Over to the bench we go. I'll show you the calibration adjuster. Flipping it over. Just at the top there, almost in the middle of your screen now, is a circle. Can you see those cogs? Those little teeth? You turn on those. Now I'm going to go to the it's never going to work on YouTube. I'm going anti-clockwise, alright? I just put a screwdriver in there and just pull the teeth just slightly across, and that gives us a bigger deflection. So we're going to just turn them little tiny, it actually connects to the mechanism there. Let's try and put it down. Can you see it from that angle? Bring the light across. You want to show you through the magnifier? Why not? You can see it. That little, just above the peg. So I'm going to go across to the left a little bit. Alright, here we go. I'm going to adjust that in and see where we sit. Screwdriver, this one will do. Don't tweak that little wheel. Just as a double measure, I've reconnected that first gauge, not R1. It definitely goes just over the white line. Don't do it. A child is born with no state of mind, blind to the ways of mankind. Yeah, we're in that little box, aren't we, boys and girls? Aren't we, boys and girls, in that little box? Okay, now that I've tweaked this, we want that to be in that little box. We want all the gauges to be the same. Symmetry is a lovely thing. Do you organise your record collection in alphabetical order? I don't. But it would be nice to. And we're fueling up. Where will we land? Do you want to play fuel gauge lottery? Slow, isn't it? Will we make it? Where will it end? Where will it stop? Have we turned the wrong way on the adjuster? Approaching. Gauge just moved on its. I think we've gone worse actually. We're actually exactly half. I'm sure we've gone to the left. Mind you, I have moved the sender from the first check, so we can only compare it with the last check. What we'll do now, we'll do a full tank check, and it should land between the two dots. I know that's how they do it. So, full tank, por favor. Full tank. Do we go between the dots, or do we go more to the left of the dots? In which case I turn the adjuster the other way. We need to be hitting between those two dots, folks. Before we didn't even, well, we did just cover the dot. If you remember, we had it just at the end. Knocking the radio down. Yeah, I reckon that's done its less. I should go the other way, I think. Let's go the other way. I think that adjustment made it less. Okay, time to try it the other way. It definitely wasn't the other way. So we're going back the other way now. So just undone what I just did and just gone more on the original setting that we did, and it's working. That's the right way. We're entering into those dots. So that calibration screw does do the job. It's got to know which way to turn the little teeth. So we're approaching where we were earlier. We should just go over that, because I'm actually over the original position. It's early days yet, but I think it will. I think it'll uncover the other dot just. And if it doesn't, we know which way to adjust it. There's still plenty of adjustment left. Paint drying springs to mind, folks. Sorry about this. A little bit more, do you think? Okay. Just a touch. Nothing more than, nothing less than success. Although I'd have accepted that as a full tank. But I'm just going to, just one minute tweak, please. Oh, shall I tap it? Just see the other dot coming in. Give me a little, just a little bit more, please, please, please. Now then, what do you have? What do you say? What do you say? Are we going to go off the scale? Full tank. Just between the dots, please. Off the scale almost. Let's compare that now with where the other one sits. If they're the same, we're okay. I might come back just a little bit because I think I'm just over the top. You can see what I'm trying to do. I won't bore you with any more. We know where we go, what we're doing. Just trying to get that to sit just where we want, and then matching it with the other existing gauges. Simply because I've added a little paddle on this. That's all, just in case it affected it. I'll leave this now. No more calibration on it. We know what we're doing. We got it the best we can. Okay. I'm going to settle at that. Okay. So fuel gauge is done. Stick it on halfway. We can't quite match the other gauges, but we're not blooming far off. It's one of them things you could spend a lifetime doing it. I think my gauge could be as good as the others. You know, if this lands just around the half, then that's great. And we've got the pod paint dry while we've been doing this too. This is more like it now, just slightly over there where the other one was. Beautiful. And I complain at that. As it just settles. If you remember, we were just touching it, so we're good. Let's try for zero fuel. Going for zero fuel now. Zero fuel. Right the way down. Whoops! Disconnected the sender. Because there always is a little bit of current just there, even when the tank's totally empty. It still sends out a little signal. Dropping down, you'll hear a relay. Oh no, I'm not connecting them, but if normally you'd hear the low fuel relay kick in as well now and send the alarm off, but we're not going to hear it because it's not plugged into the loom. Approaching there, it should drop into the red, which it will do. As long as it touches the red, we're fine. Anywhere in the red will do. Bullseye moment. Go on, give us the quote. But well, you could have won. Approaching the red. That's all right for me. Out of fuel. I think on this, when the sender float bottoms out, you've still got a reserve as well. So the red would indicate we're into the reserve part of the tank. So that's good. Can't say fairer than that. In fact, it's coming into those two calibration dots. Can you see? Virtually the same point that it lands on them up at that end. So we can live with that. And drop it even a little bit more. It takes longer to cool than it does to climb. I told you I wouldn't go back to this, didn't I? This is landing in the calibration dots. I think you can live with that, can't you? How would you go? Would you carry on going all day? This is fine. we'll leave it at that, and I'll show you the pod now it's paint's dried. And here's our chrome finish on the pods, nicely done, and that paint gives a lovely plasticky type look. It's not too glossy, it's not too dull, it's just the right sort of finish, Ford type paint finish that they used. So we've masked around those chromings, that gives you the chromings, not too much chrome, not too little. Nice piece, so we can put the gauges into that. It still needs to cure a little bit, so I'll be careful with that. Whilst it's touch dry, it'll still need to fully harden. Going over plastic, it does eat into it a little bit, and you get a bit of adhesion, but I wouldn't give it high rating scratch proofness, because even the Ford stuff scratches off. You see it worn around the key ignition area and stuff like that, so we'll be careful with this because it's fresh paint as well. Okay, put the gauges in this now, we're doing good. With the pod in and the light on, you can see how beautiful that little fuel tank icon looks. How nice. So we're done with first pods in. Just be very careful because the paint needs to cure. But I thought I'd give you a little treat. Ah, so nice that. I love that hue, that blue little crescent that you get. Just looks lovely. Right, it's the end of the day for me. We've done good there. Rest of the gauge will go in a lot easier. Calibrate the temperature gauge as well. It shouldn't need much to get it right. We can do that now. We've learned that calibration screw. Brilliant. And there's the fuel. It's fully empty position. That's great. I think you'll all agree at home. YouTubers and Patreons, a special treat view for you. Lovely. Still shot. See you in a sec. Just a little thought on the conical lens we talked about. I wonder if they added it halfway between when customers complain you couldn't read the gauge, because the conical does act as a magnifier. I'm wondering if the first ever ones were flat, totally flat lenses, and then someone said I can't read them gauges, so they thought we're knackered now, we've built the pods, so they fitted these conical ones to try and magnify it perhaps. Just a little thought before I close. Mind's always going. Inquisitive minds. See you in a sec. Guess who's back? And guess who achieved perfection? I think you can see what I can see. A needle resting between the calibration dots. Oh hell yeah. I couldn't help myself, could I? Full tank, sat between the dots. Zero tank, sat between the dots. I came back. Hey, you know what I'm like. Oh my god, why? Oh why, oh why. I did it. Houston, we don't have a problem. We are up, we are running. We are superb and adjusted. Just one time. I said, just please. I went in the house. No, just give it. Just please. Boom. See ya. That hat suits you. It was too big for me. It just didn't. I have got a big head, Pete. No, it just didn't suit me. That's all I'm saying. Seatbelt, Frank. It'll be bleeping forever. I sure do know.
Come on, Brett.
What do you think of the Mondeo then, Frank?
It's nice, Pete. It's nice. How many sort of kilometres has it covered?
Oh, miles. I don't know. I've looked. 150, I think.
9 years old. 9 years old.
Where are you? Get that seatbelt buckled up.
Velour seating. Yeah, nice.
I've inadvertently switched on my wipers. Fleetwood, Frank. Fleetwood.
Ah, no. The Co-op bought it. I can't believe it.
Now this road. You remember when we cut the roof off the Cortina?
Yeah, remember we walked over there from the side.
Oh yeah. Frank, remember? Frank, things have changed. Remember this road? Trying to get the Cortina down here.
Yep.
Wow.
Bucky's the pole. Well, homage to the pole. Homage to the pole.
Yeah, this you're referring to the telegraph pole that we installed. Yeah. Is it still there?
Homage to the pole. Monkey seat. Homage to the pole. Homage to the pole.
Wow, Frank, things changed. Everything's overgrown.
There it is. There it is.
Yeah.
Has he got his camera on
The
it?
Cortina went into this driveway here, look, with no roof on. We turned right here. I should have put a clip up of it. Down there, down that drive. Wow. Driving down this road, a Mark V Cortina estate with no roof on it.
The place! We just come.
Father Christ. Where was he going? On board action! He's going down the road. I don't believe he's going down the road. Fucking hell.